Hello, everyone. It is Wednesday, the 17th of March. Happy St. Patty's Day. If that's what you do, you do you. I see a few people wearing green shirts. My wife stopped by earlier and made sure that I was representing that meteorite's wearing a St. Patty's Day hat, for crying out loud. So we're fully in effect today. Gonna have a really good hangout today. I know for a fact because I'm a I can see the future. We had a little bit of a change up with one of our tour of the universes. Juan Aviles was going to do our tour of the universe today, but he got called to Niger. So he is in Niger right now, and he's buying dino teeth. Yes, dinosaur teeth. He's a paleontologist, and that's what he was into seriously before meteorites, and he still does it very well. So we have Jesse Allen from Australia. Yes, folks. Australia in the house, Belgium in the house. And I think we might have a Canadian too. I'm not sure. But we're going to have a little tour of the universe. We're going to continue with our very popular, actually. I got a lot of good feedback on the Meteorite 101 class. So let me just go ahead and share this screen with you guys real quick, and we'll jump into some of the stuff we're talking about. Hopefully you can see that.
Yep.
Okay. All right. Whoa, a little too much. Okay, so quite literally today we are going to be, why does it keep doing that? There we go. We're going to do some new falls. I don't know if you guys knew this or not, but there is some new falls in Tokyo and Wisconsin. So we're going to update you on those and got some stellar video. Going to do a little bit of Mars update. We have some Mars video from Curiosity, not Perseverance, and some audio of Perseverance actually driving, whirling, moving around, crunching. It's really cool, I think. We're going to continue with our Meteorite 101. Today we're going to do class number 2, irons. Ooh. I already talked about Titan and Jesse doing our tour of the universe, our eBay faker of the week, and then lots and lots of show and tell. Because the last week we really had no time for show and tell. So this just happened. And if anyone knows more about this than I do, by the way, as we go through this hangout, interrupt me as much as possible, interject as much information as you want. That's kind of the rule here. There's a new fall in Wisconsin. Went over Michigan and Wisconsin. This was just on February 11th. Now, we're really excited about fresh falls and witness falls, but if you look at the direction of travel, here's the meteorite path. And I really don't think that one's going to pan out. I don't like the direction of it. So yeah, there's a lot of Great Lakes there that could get sucked into. So yeah, that may be one that we don't get anything of, but at least we got some good video of it. So let's just watch the video. I gotta turn off my laser pointer, I guess. All right, here we go.
Oh, wow. Oh, yeah.
Did you guys know about this Michigan one?
No, not at all.
Nope.
It's amazing how much debris is entering our atmosphere every day. It really is.
Mm-hmm.
Oh, I stopped the video. There we go. This is what's cool about this. You notice they're all falling the exact same direction. Do you know why? Every single meteorite in this video is falling the exact same direction because we are looking at the Milwaukee County bus line camera system, and all the buses run in one direction. With that, we were able to catch it. So I don't know if you guys, there's a lot of little Easter eggs hidden in all kinds of plain sight. So that's just one of them, because I questioned that. I was like, I've never seen 8 separate cameras all capture the same meteorite falling in the same exact angle. Why did that happen? At the transit lines. Now here's a new one that This is some beautiful stuff. I do want to give a shout out to Skywatch Media News. I don't know if you guys are subscribed to that channel. 222,000 people are. He does a really good job of capturing events. So I do want to give, I guess, shout out or call out to Skywatch Media News. This is where I grabbed some of this footage from. And this one's remarkably beautiful. Look at how long it burns and how low to the ground.
And these weren't related to any current meteor showers going on at this time.
No, meteor showers don't generate meteorites because there's just small grains of sand and stuff.
Okay.
So the like the Orions, the Geminids, the Pleiades, all of those meteor showers are literally grains of sand, specks of dust, and that's why they burn up and they flash. So they're flashes more than streaks. But if you look at this, you can definitely see this is a hunk of something. It's burning green. Yeah. Watch how it goes from purple to blue to green. This is gorgeous. Screensaver. Oh my word. I love that one so much. We're going to watch it again. Watch this. Look at how green. It starts out purple. Yeah. See how it's purple?
Now those colors, it's a very common myth and it gets reposted to the meteorite pages about every 2 months, that supposedly that tells you about the chemistry of the rock. It does not.
Right.
We're not burning rocks. This is a plasma ball out in front of the meteoroid.
Yes.
And the color is from what gas is predominant in that part of the atmosphere.
It's kind of like an aurora. That's what it reminded me of. You see the purples and greens. And when you see the aurora borealis, depending on what the composition at that moment is,
it's ionizing something, you know.
Well, this is like a ball of plasma right in front of the object that's entering the atmosphere, correct?
Yeah, the air gets compressed greatly, and incandesces. Oh, that's pretty. And incandesces, and the light that we're seeing is actually from that plasma ball.
Right.
Man, that's gorgeous. This one right here is just. Now you know, yeah, beautiful. Now, last week we were kind of joking around because one of the definitions we were educating about in the 101 class, a meteor is in space. A meteorite becomes a meteorite once it touches the ground, once it hits Earth, you know. Well, this is a meteor what? Because this is Renchen. It was a witness fall in Germany, and this little 5-gram stone I talked about last week, I thought it landed in I heard it landed in a canopy. I didn't know what type of canopy, but it was a canopy net protection over some blackberry fruit and stuff. So I thought you guys might enjoy seeing that as far as a meteorite. I think I'm going to hit pause for 1 second and let's go to some show and tell. Does anyone have something ready? Raise your hand and we'll come to you, I guess.
I have something. I'm just not quite downstairs yet.
Okay. Well, I do have a hand up, so I'm going to hit pause.
So
we're back with Pat.
Hi guys. So this one's been waiting in the queue for show and tell for a while, and it's lost some weight. This is the 8333.2 gram chondrite that Topher picked up for me at the Quartzite show, and it has met with the saw. So wow. It's about 1.5 kilos or so lighter than it was. Now, one of the things that really attracted me to this, and then Topher was doing a live event at Quartzite this year, and of course, because we don't have the Tucson show, everybody's jonesing for looking at meteorites, including me. And so I saw this one on the table, and it's like, it's kind of in the background, and it's like, yeah, that's interesting. Oh, I don't know, that's interesting. So anyhow, but after hemming and hawing for a few days, I decided to go for it. And the cool thing about it is it's got these holes in it. And I was wondering if they were chondrule blowouts, but after some more work and some cutting, it turns out they're not. They are actually Troilite weather outs.
Make sure your mic is in. Make sure your mic is in range too.
Right. Okay.
Awesome.
This one, and I'm playing around with the Droid cam, but I haven't got it working yet, so we're going to have to suffer with my webcam. But this is not completely polished yet. But this meteorite has almost no metal in it. It's got lots of troilite or some other sulfide. There's a couple of other ones that are common. And so as I was looking at this thing more closely, I realized that it's got a bunch of, sorry, this one's not lapped yet, but it's got a bunch of barred olivine chondrules in it, like a disproportionately large percentage of barred olivine chondrules.
Oh my God.
So I stayed up till 4 o'clock in the morning, getting out the books and doing some research. And it turns out that these characteristics all kind of line up for our chondrites. So it could be in our chondrite.
Oh my God! If that's a Rumuruti, you hit it out of the ballpark.
Yeah. Well, I hit it out of the ballpark anyhow because it's a cool looking rock. Yeah. But yeah, it turns out to be a Rumuruti. And so I'm already in discussions with our classifier to the stars.
Wow.
Daniel Shake. And
remember who hooked you up.
Oh yes. Oh yes. Yes.
I'm a collector. Yes. I'm a collector first before a dealer. Trust me.
So,
hey, quickly before you move on, are you able to tell us what Troilites are?
Yes, absolutely. Thank you for asking. So,
and then I want to show what a barred olivine is because I have that here.
Okay, cool, good. So, so this lighting is very specialized. This is reflected cross-polarized light, and I'm rotating the polarizer in front of the LEDs. But normally in meteorites, ordinary chondrites, we see little flecks of metal. And this one actually does have, after I polished it some more, actually does have a piece of metal right there. Mm-hmm. And if you look at it into the sunlight just right, there's some other teeny tiny little flecks.
Can you remove the cross polarization right now to show us the metal better?
Yeah, so it
there we go.
It kind of washes out a little there. Yeah, there it's recovering some.
But we can see the big blobs now. Are those all big? There's like 8 big blobs.
Right. So those are not metal. Those are troilite.
Okay.
Those are iron sulfide, FeS. And
is that what happens to iron when it gets old?
This is probably directly from the solar nebula or the protoplanetary disk. When we see armored chondrules, it's not actually metal around the chondrules that we're seeing. It's actually troilite in most cases. And so,
how do you spell that, troilite?
Troilite.
Thank you.
And so this one having a bunch of barred olivine chondrules, having very little metal, abundant troilite, and even larger troilite nodules from the weather routes in the overall stone in the crusted surfaces. All of that kind of points towards our chondrites. So that
is fantastic.
That's a pretty interesting one.
Wow.
And
thank you for explaining that.
Yeah, you bet.
Pat, I'm going to interrupt you for one second, because I do want to we want to be interrupted when we are saying things that you guys don't understand, and we can always reiterate and go over stuff. So thank you for interrupting and interjecting and saying, hey, I want to know what that means. This is one of my little cheats that I keep playing around. It talks about different chondrules in chondrites. So the very first one here is what Pat is talking about, a barred olivine. So when you actually dig down, or look at the chondrule, it's going to have this kind of formation in there, and that's called a barred olivine. Now there's several others. I'll just show them off kind of quickly so we can just get a glimpse and a name of them. I'm definitely not going to try to pronounce them all because I'm not a geochemist, but they're like radioproxine is really cool.
And the radiopyroxene chondrules are beautiful under the polarizing microscope, because when you spin the slide, they undulate in the way they go to extinction.
And we've been talking lately about poikilotic Martian. Well, there's a poikilotic one. So there's different kinds of chondrules. We were talking last week about the size of the chondrule and about different information surrounding the chondrule. But now we're actually digging down into the chondrule, and I'll shift it back over to you.
Yeah, so we'll have to do a meteorite 101 on chondrules. But speaking of chondrules, this one came in the mail the other day.
Wow! Oh my gosh!
That's a huge chondrule, if that's a chondrule.
And yes, that's a chondrule hanging out of the top.
Wow.
Now in the upper right.
Wow.
So this thing is
1 second.
pretty much just a sea of chondrules. And when you look at it closely under the microscope, there's little chondrules in between the big chondrules.
How much weight on that one, Pat?
This one is 282.2 grams.
Oh, nice.
And the other cool thing about this one is that, so this is an ordinary chondrite, but it's a type 3. And then the next question is, well, is it an H or an L or an LL? So here's my standard magnet, neodymium grade N52, the highest grade, highest flux.
Against a 300 grammer.
Yeah. And if you get exactly the right spot, you can make the magnet move a little bit.
There is very, very, very little iron in that. So we learned last week that means it must be what class, everyone? Is it L, LL, or H?
LL.
Hello.
Correct.
LL, yes. The other big clue for LL is the chondrule size. In H's, you'll find small, uniformly sized chondrules. L's sort of medium size and fairly uniform. And in LL's, you see big chondrules, and you see lots of variety in the chondrules too.
I got a thin slice here with a nice chondrule on it from a CV.
Cool.
That is absolutely gorgeous. I know we hung out a few nights ago and I scoped that out already, but still, it's gorgeous, man.
This one,
turn that down, or it took me out.
Fresh out of the mail. This one is a very newly classified, was just in the last Meteoritical Bulletin. This is NWA 13772.
Wow. That has a CIA in it?
It looks like a CAI, but I think it's actually a chondrule.
Wow.
It has a chondrule sort of texture inside of it under reflected cross-polarized light under the microscope. But this one was just classified as an L3. But I think this is an example of not doing enough lab work. It's wonderful that it got classified, and I'm super pumped to have 3 slices of it out of a pretty small total known weight. But I think this is almost certainly a 3-point something. But doing the extra work under the microprobe to look for the early signs of metamorphism is expensive.
Definitely worthy of doing that. But yeah, I was just gonna say that's the only drawback is the subtyping is what we are referring to now. Once you have a 3 to a 3.1 or 3.4, that is a subtyping. The type is a 3, the subtype is a 3.2.
Yeah.
And that costs extra money at the lab.
Yeah, it's on the order of $450-ish. This one's in line for the saw. I haven't decided exactly how to hang on to it yet, the saw, and this one will get subtyping.
Yes.
I don't know for sure if it'll go, but it's going to get a chance to go.
Yeah, that's awesome. I'm really pumped. And just to show that, this is the Topherspin Meteorites hangout, but we're agnostic and we have a lot of friends. This one was a Matt streaming meteorites purchase.
Yes, thank you, Topher. Yeah, Matt has my user profile dialed in. This one didn't even make it all the way to his house before it was sold. He picked it up at lunchtime at work and emailed me from work in the afternoon, and it was sold before it ever got home.
That's awesome. Yeah, that's gorgeous, man. Wow, that is fantastic.
Thank you, Topher.
Yep, I'm gonna pop over to Arthur because he's had his hand up since last week. Arthur, I hope you're ready.
Yeah, my hand fell asleep.
Yeah, we couldn't get to you last week because we had so much good stuff, but you're almost first this week. Go right ahead.
Well, I have a Benccubbin that I received from Mark Lyons, and I was going to show that. I don't know how good it will show up on the camera, so let's see what we can do here. And gotta have this switched around. There we go. All right, I just have a slice of Benccubbin here. It's 13.87 grams that I purchased from Mark Lyons. And what I found interesting about this, if I can hit it with my pointer here, there's a little crevice in here running diagonally, and there are tiny, what appears to be silicate crystals in there that are water clear. I don't possess the knowledge or background to know what they could be, whether these happened naturally in space or once the meteorite was on the ground. And, however long it was lying in the desert or whatever, that bug was filled, or that crevice was filled with terrestrial minerals. So, but it is quite interesting, and the pattern on it is kind of unique. I asked Mark if the gentleman who cut the slice for him could polish it some, but I guess this is a type of meteorite that's not easy to polish, and obviously it doesn't have any terrific Widmanstätten patterns, but is a mixture of metal and minerals, I guess, in there. So, but I'd have to go to the Met Bull to really read it thoroughly to try to understand it. There's a lot of information on here. This is a CB, but I guess there's also a Benccubbin that falls under CA.
CBA.
Don't hold me to that. I don't know for sure.
Yeah. And
but
Benccubbins are extremely rare. So having a 13-gram sample is quite an accomplishment.
Right. The Met Bull said there are only 7 of this type known in the world.
Yeah, that's beautiful.
So,
and Mark is he's not self-professed. I'll go ahead and call him the Benccubbinite king. He's got some crazy stuff, Benccubbinites. While we're on the subject of Benccubbinites, I'm going to show off my Gujba. So this is a Benccubbinite. This is the CBA version. And this is what Gujba looks like. It's really super unique and cool looking. So this is about 7 grams, I think.
Mm-hmm.
Beautiful.
And it has the same feature you were talking about with the voids, but they're not really voids. It's full. It looks like a void.
Yeah.
Even if you go diagonal, it looks like a void, but literally my pointer goes right over it. So,
well, I put mine under 500 power scope, and the light was reflecting off of the crystals. And if I was to describe them, the crystals look like little bubbles of, quartz or something. There were no facets, no faces, and no pyramidal terminations, So,
what do we know about
like I say,
yeah, we really don't know how it's formed. There's lots of different theories out there. You notice how usually the round things are the silicate chondrules and the matrix is in the middle. There's metal flecks in the middle. But what we have in Gujba, and I'm very uneducated about this, but you see all the round metal, and then there's silicate inclusions in here as well that are more opaque. Now, again, this is not one you're going to over process because it's 100 and whatever bucks a gram. So once you have one pretty side, you leave it alone. And that's the pretty side. But these silicates are really complex too. When you zoom into them, see there's all kinds of chondrules and crap in the middle there too.
Yep.
So Benccubbinites are extremely rare. And when we look on the chart later today during the 101 class, well, we can actually spotlight Benccubbinites and find out how rare they really are, because they're quite rare and their price is reflective. Their value is reflective.
Now I'm looking for a black beauty.
Yeah, I can show you my black beauty, but my cell phone doesn't zoom that much. Does
my wallet doesn't open that much either?
Yeah. I open it up to anyone for show and tell right now. We got Maxime with his hand up, so awesome. I'll go ahead and spotlight Maxime and go for it, buddy.
Yes, so I did not prepare the video for today, but I will show something live, so I hope you will like it. So first,
by the way, thank you for joining us from Brussels at whatever time o'clock it is in the morning. Thank you, Maxime. We love you, man.
So, okay, the first meteorite I wanted to show you is this one. So this is a small fragment which hit the news not so long ago. So this is the first fall of 2021. This is Punggur. So it's being classified now, and I received it as the Meteorite of the Month Club, for the Meteorite of the Month Club. So I'm quite happy to have that fragment, or that slice actually. And I will try to have a look at it under the microscope for next week and make a little video about it. But what's nice is that you can see, I don't know, I think my camera is not good enough, but you can see that there are some large metal flakes in it. But I think
definitely throw it under the scope. It's got some great green crystals and chatoyans to it.
Okay, so I'll definitely do that for next week. And then the second meteorite I wanted to show you today is an unclassified in the WA, which has a very nice feature. So here it is. And what is nice is that it's like a fusion crust gradient on it. So again, the camera quality is not very good, but here the crust is quite fresh, while here it's heavily sandblasted. That's really interesting to see. And on that side here, it's mostly desert varnished. So it's an interesting specimen, and I'm quite curious to know why it looks like that and how it was in the sand to make that.
Yeah,
here.
That's a very good. Where is the freshest crust on it?
Here, right here. Here
wow.
And here it's sandblasted.
I can't figure out the orientation of a terrestrial either. You know what? It may have, sand dunes move. They don't stay still over eons, they move. So it may have been not only oriented in flight, but oriented in where it sat on Earth for 10,000 years, getting weathered extensively, and then flipped over as a sand dune moved. And then, 50 years later, it was found. It's a good theory, prove me wrong. That's awesome. Yeah, that's beautiful.
It is. It is.
I have a question. A question for you. I noticed you have some tattoos on your arm. Yes. What is it? Is it science related?
Here it's like engineering related.
Oh, nice. Yeah, good. I like that.
Yeah, on the other arm, sorry, it's not really science related. It's more something else.
That's cool. Well, awesome. Thanks for showing up and showing off. I like that, man.
No problem.
Good deal. We have Cameron. The reason I asked about his tattoos is you can't tell by looking at me, but I'm pretty inked up. Wherever my shirt's covering has ink pretty much, but I have my tattoo classifications on my arm. And by the way, yeah, it was Pi Day a few days ago. So, I have 2 new classifications I'm going to get added on there. My Beast with Martin Lawler, and then my brand new Winonite.
Yeah.
Let's kick it over to Cameron real quick.
All right, so yeah, I'm trying to make sense of this giant lot Jody got for me from the. She actually got it off the thrift store auction site. I mean, there's multiple copies of a bunch of this stuff. Several different examples. Anyway, but I had to follow Michael Kelly's example and get my own piece of Axtell.
Nice.
Oh, sweet.
That's a hard to get one.
What's the classification on that? Is that a CV3?
Yes, there it is.
Okay. Wow.
CV3s were uber rare until the end day happened.
Yeah, it came sealed up in this, and I have another meteorite from this collection. I've got Selma, and it was sealed like this, and I couldn't bring myself to pry it out of there. So it's.
And if I remember correctly, didn't you put a post on Facebook asking who packaged their stuff like that?
It wasn't me, but someone did, and I'm not sure that we ever got an answer.
Raymond here, I was asking that because I got a bunch from Grant Harkness and those packages. I've got Landis and a package like that, and just a few other ones. Someone bought one and posted that it was from Bob Hagg, which I don't know. Maybe they sold it to the person who packaged it up, but we don't know who exactly it belonged to. They left it and they died, and then their collection was sold.
Wow. So. Thank you, man.
So yeah, that's exactly who I got mine from. I got mine from Grant Harkness also, and I don't know if my camera is gonna show you all the cool little chondrules.
Oh, there's a bunch of beautiful chondrules in there.
Yeah, yeah, absolutely.
So,
oh no, they're visible.
And then another recent edition is tiny little fragment of park forest.
Ah.
Oh,
With
wow.
My just a little bit, yeah, just a little bit of that crust, but I feel like my park forest isn't really complete because I know that there is broken glass out there that I need to add. Yeah. No park forest display would be complete without.
Tell the story of the glass.
It is, if I'm not mistaken, this is the one that hit the moving car, isn't it?
Correct.
Yeah. Ended up in the back seat.
So there's that. Maxime has already let the cat out of the bag as far as the meteorite of the month, but this is my.
You got crust.
This is the entry I submit.
Very nice.
Man.
It's 3.5 grams.
Mm-hmm.
So yeah, if you
wow, look at the shine on the bottom.
It's all over. It's just it's just, you know, that's where it shows up the best right now, I guess.
Yeah.
And yeah, for something that hit the ground, you know, in February, and now this is March. I had it last week when he was showing off the main mass, when Roberto was showing us the main mass, and but you know, we didn't have time for everybody to go and show off their rocks. So this is it's the meteorite of the month.
Yeah, and again, I'll give my friendly competition a plug, man. If you're not subscribed, if you're a newer collector and really not sure where your focus is, I'll tell you right now, $50 a month, $100 a month, whatever package you buy into, like that, you're on the $100 a month plan, just to be clear, right?
This is the $100 a month.
Yeah. Okay.
Yes.
And you get something super cool, super unique, and like you're basically stealing it. You're paying for the freight and the case.
So, and you know, I swore off Galgini's ages ago, but I couldn't pass this one up.
Oh, man.
It's got that little lip on there.
Absolutely.
So yeah, I got a really big
box. Is that a shield?
Yeah, more or less.
Yeah. Wow.
Yeah, and nice shallow regmaglyphs on the backside too.
I figured he had some character. I got it for the low price of being friends with Steve Arnold and paying $8 shipping.
Wow.
So
excellent.
I am
remaining, yeah, for $8, right? How can you say no to that?
I'm remaining.
Congratulations.
I'm remaining loudly silent right now. Extremely loudly silent.
Yeah, I know you are.
Great piece, Cameron.
That's why I have to make sure I show you.
It's beautiful, man.
That's all I had. Thanks.
Yeah, awesome, man. Yeah, I definitely appreciate you showing stuff off. Let me remove the camera off you.
I got some stuff here, Park Forest. I'm not sure how to raise the hand and zoom yet, though.
Well, I'll tell you what. Since we just had Park Forest, I will highlight you, and we'll go to Jan's next. Is it Jens or Jan's? We'll find out in a second. Hold on one second. Yeah. So that's Park Forest was a hammer event. It nailed is that the Mendoza house or the Garcia?
This one is Garza residence.
Garza, yeah.
And then this is pieces from the car, apparently. This is from Mark Bostic. He says, what does he say? Windshield hit car. Windshield, Illinois. Park Forest windshield. I'm not sure what these little pieces of vinyl in there are.
Yeah, I'd be very. I don't think they're parts of the car. I think those are part of the house, the Venetian blinds. The meteorite went through the Garza residence. It actually went through a window, hit the door frame, the window frame, and that's what you have in that kit there from the Hague. Yeah, that kit right there actually has wood from left to right: wood, drywall, window, Venetian blind. Not that I have one or anything.
Yeah, and this is actually this was the first kit that Greg Hupe made.
Oh, Hupe, yeah.
Nice.
Oh wow, 1 of 200. I'll trade you mine for that one, straight up.
Yeah.
That is freaking awesome.
The other thing, it's Troilite. I actually have a specimen from ASU of just Troilite. It's not a meteorite. It's a mineral from ASU. I don't know if it's in focus there. Let me see.
Yeah, pretty hard to see, but it's cool having the ASU provenance on that one.
Yeah.
Can't figure out how to get it to autofocus. Looks like it just has to be kind of far away.
Yeah. I'm super jealous of your serial number 1, man. That's seriously. I love. I would love to have that. Let me just show you something real quick. This is Cameron's. This is actually going in the mail to him soon. So I'll show you what yours looks like. This is Park Forest windshield.
Wow. Oh yeah.
So that's yours, buddy. It's on its way to you. Well, shortly.
That looks nice. Thank you.
Yeah, pay your bills. No, no. I have your pile set aside. This is safely on it. Let me go ahead and go to Jan's next. So,
can you hear me?
Yes, we can.
Yeah, hi. I'm Jens from Germany.
Jens, nice to meet you, buddy. Thanks for joining us.
Yeah, I found your channel a couple of weeks ago, and yeah, since then hangouts, and today I have to learn for an exam, so the night is long, and I spent a couple of hours here to join you.
Good deal.
Yeah, I want to show you a couple of my own finds. I spent 2015 on the Mandrabilla Strew Field in Australia for 3 days, and done a little bit collecting there. And yeah,
I'm jealous.
I was a little scared when he started off by saying, I want to show you some of my finds, and then he redeemed himself totally.
Yeah. My webcam is not the best, but that was the first one we found. Yeah.
Is that the first meteorite you've ever found, or
yes? No. Actually, that's the second one.
Okay.
The first one was a stony one on the way to the strewn field.
Oh, nice.
Yeah.
That looked to be about 50 grams or so. That's a pretty big one.
36, yeah.
30. Wow, nice.
But this one has over 250. I have no exact idea, actually.
Wow.
It spends a couple of months in the cupboard, and yeah.
Wow.
It's a bigger one.
Yeah, it is a bigger one.
And the piece was...
You don't find a whole lot of like Mandrabillas affordable in a 200 gram plus range, man.
Yeah, that's true. And one with that's too much reflections. I have had done cutting.
There it is.
Hard to see, but it was a 101 gram piece, and now I have 2 with nearly 50 grams. Polished and etched Mandrel.
So nice. That's actually your find that's been cut and etched.
Yeah.
Fantastic.
Yeah.
I mean, how difficult is it to access that strewn field?
You have to enter from Adelaide or from Perth with a 4-wheel drive, and in the middle from the Nullarbor Plain. There are some dirt tracks to the railroad. The railroad crosses the strew field, and yeah, you need roughly 4 hours from the road, from the highway to the street field.
Cool.
And yeah, take lots of water and lots of food with you.
What is it you notice first when you're looking for them in Australia? The shape? Because that particular meteorite, I believe, takes some unusual shapes to where people see like animal figurines and such, or is it the color of the rock that is different from the surrounding rocks?
Yeah, that's in Calc Plateau, Cretaceous Plateau. So you have no other stones there. So it's great to hunt for tektites too, and for stony meteorites. But the Mandrabilla ones are iron meteorites. That's an AB ungrouped. So we used metal detectors to find them.
Yeah, okay.
And
Nice.
some of them were totally buried.
How deep were they? I was just about to ask that.
They lying on the surface up to 20 centimeters deep.
Okay.
So I'm sure there are bigger ones lying in shallow depressions, but yeah, hard to find.
Wow.
And a huge area.
Yeah.
What
Big-
made
big
you
dream.
think of that specific meteorite to hunt as your first hunt?
Yeah, we spent a year in Australia traveling around, and it's a little bit on the way. So
That sounds like a trip of a lifetime, man.
yeah, it is. Wolf
Wow.
Creek Crater, Dallaranga Crater, Henbury Crater, Big Bluff, all the big meteorite craters visit in Australia, and yeah, great year.
Thank you so much.
Cool. Well, you know, in
No, that's awesome.
upcoming here in 2023, the Meteoritical Society meeting is in Perth. So I'm considering a little Nullarbor expedition afterwards.
Yeah, do it. Definitely do it. Take a metal detector with you and go hunting. There's lots of meteorites to find there.
I'll take your advice.
Yeah, I love these hangouts so much because I've never met Jens before. Jens or Jens? Jens. I hope.
Jens.
Okay.
Yeah.
I've never met Jens before. As you can tell, I don't even know his name, but he found us on YouTube.
Yeah.
And and I say us because we're a crew, we're a team. One thing that can I ask everyone watching this video right now, hit the like button, because that way YouTube will show us to more people and we can get more Jens online with us, because that makes my heart happy having someone brand new join us from Germany who's traveled to Australia. Just that's good stuff. Glad you're with us, man.
Thank you.
We have Michael Kelly with sporting the hat.
St. Patrick's How's everyone doing? So, happy St. Patty's Day. So you don't start out a meteorite hangout on St. Patty's Day show and tell without a little Irish show and tell. So there's Crumlin, Ireland right there. So Erin go bra on that. But
how many Irish meteorites are there?
I do not know off the top of my head. I know there's at least 2.
Okay.
But that's the only one that I have.
Because I have a huge one to show next. So
there you go.
Yeah. So I don't want to ruin your thunder. It's nothing important, but go ahead.
So with the quietness on the last couple of weeks, doing a lot of great videos. A lot of new things kind of came in. So this is kind of a cool one if it focuses in there.
That's Mars.
That's a little more rare than Mars.
Oh, it's an angrite.
That's an angrite, yeah. 99555 angrite from the Laban. So that's old school angrite.
Wow. So they go back to that one for a second, if you would, please. Angrites are extremely rare, and that is a Sahara. So that's pre-NWA. That's before we got to the NWA numbers. They started with Sahara numbers, correct?
Yeah. They had it separated out, and it's a 1 of 35 currently. So there's 35 of them, and that's a fun one. I keep track of how many there were when I started, and there was only like 24 when I started, and I've only been at it for 3 years. So they have been turning up more lately. You know, they've been doing a lot of good chondrite finds out there as they get better at figuring out you know, what the unobvious meteorites look like nowadays.
Correct. Yeah. Awesome.
And the
Thank
gentleman who first found those, he was very secretive, I believe, as to where his search areas were for the meteorites.
Yeah, that was probably Dior Bigny. Yeah.
Sticking with the Laban pieces. This is another Laban. There's also a Sahara 99456. So this is a E6. So it never got dumped into a group. So it's sitting out there floating in not group status. I won't say ungroup status because ungroup means that it can't be put into a group. But that's kind of a cool old Laban piece, and there are 8 of those out in the world sitting in E6 status.
And just a reminder that Mike Kelly, his goal is to collect one of everything class-wise. Like he's a class whore.
Yeah, shooting for all the subtypes. So I'll give you a little teaser when we do the irons. Hopefully, we'll come back to that later.
Yep.
But there's
yes, my
irons.
God, that's awesome! A whole row
Irons
of knowledge.
later, we can cover that.
Yeah.
This is kind of cool. This is definitely not my. You know, there were a lot of people showing off large, nice Allendes. You know, this is a smaller piece that I got, but I was looking for a piece that came out of the Sam Goldich Collection. So this came up a little while ago, and Sam Goldich was actually a very important geologist. He figured out the decay rate for different minerals that we have, which translates over the same thing to weathering in meteorites. So when you're looking at magmatic meteorites, the ones that crystallize first out of the magmas are also the first to decay at the surfaces. He pioneered that series, and they called it the Goldich series. And the last little bit I got is this little guy.
That's great provenance, buddy.
Yep, and this is a CH3, so I thought that was kind of cool because there aren't too many of those out there. And this was a 1 of 27. And I got
early NWA number too.
Yeah. This is 470. I got a couple kids who want to say hi to you. I don't know if you could show them a meteorite right now, but why don't you just say hi real quick?
Hello.
Hi. Your kids' crew.
Happy St. Patty's Day. Awesome.
Happy St. Patty's Day.
Hey, see you guys. That's awesome. Well, I want to show off a meteorite because it's a little bit of a surprise that it's St. Patty's Day, so I'm gonna try to see if you guys can ID this. Give me 1 second. All right. I don't want to show too much. Is this an African northwest? Is this like a northwestern African, or is it an Irish meteorite?
I'm gonna say Irish because
it's Irish.
There is a giveaway.
Okay, I'm sorry. I just wanted to be stupid.
You're crazy.
By the way, there are 9. Make that 9 approved meteorites from Ireland.
9. Well, and this is not one of them. My wife wanted me to put that in my hair, and I was like, no, thank you.
One of the unapproved meteorites of Ireland.
Yeah, exactly. We have Alex Mann next up. Can you unmute yourself?
What's happening, everybody?
Awesome. Welcome.
Yeah, thanks so much for having me, guys. I just got this latest piece last week. See how it shows up here for y'all. Any guesses on what that is?
Very nice lunar.
Yeah. Yes, sir. And I think that you have a much bigger piece of this, Topher.
Oh, that's Tuat 005.
Yes, sir. So I got the nice ID plate along with it from LA Boltrix, who I highly suggest working with. Awesome guy.
Yeah, he makes those cases. He puts a lot of effort and quality into those cases, man. Let's show that display off again, because that's...
Sorry about the background. I was trying to be cool. Didn't work out. But yeah, I wanted to plug in that as well for LA. Just being an awesome guy. Highly recommend these displays for sure. I'm not sure how much they cost. He threw that in on this one. But
wow. That's generous, because I'm not saying anything about his pricing being high or low. I'm just saying those cases are expensive.
Yeah, he gave me a killer deal. I was celebrating 5 years of sobriety, and he came out with a big heart and hooked it up. So not a lot.
Congrats! Wow, that's awesome. He sounds like a great guy, and congrats on 5 years, and also a beautiful lunar. And it's nicknamed the golden. I'm sorry, the stained glass lunar. So have you looked at it through? Have you given a good light through it yet? Test?
Oh, you already know it.
Nice. Yeah, it's weird how meteorites get nicknames. And really, there's so much about meteoritics that is science driven, and you can't make things, you can't name things, you can't get cute with stuff. But there is one time where you can get creative and be fun, and that's when you nickname a meteorite. If it's your classification and you want to give it a nickname, as long as it doesn't, misrepresent what it is, you can give it the nickname. So on my pallasite that I had classified, it's a golden pallasite, I requested number NWA 13579. First time and only time, it's all odd numbers. You're gonna have to wait a long ass time, because 13579. So it's the odd numbered golden pallasite. I nicknamed it, and that's what it is. 2-005 is nicknamed the stained glass lunar, and probably a lot of people have heard it called that before. That's my name. I gave it to it. I was working with Mark on it, and we're looking at the piece, and I'm like, dude, I got the name for it, stained glass lunar.
It's your child now.
Yeah, so that's what it is. And there's also like the legendary. Does anyone know what the legendary lunar is? NWA 5000?
5,000, yep.
Yeah. Adam Hupe one. All right, Marissa, we are ready to go to you if your camera and everything is ready. Let me see here. Hello, Marissa.
How you doing?
Hey there, doing well.
Yeah, so since you opened up with falls, I got recently a couple of new meteorites from a fall that I was trying really hard to get about a year ago, but nobody was wanting to sell to me. Like, I kept inquiring. It was the first time I was inquiring, and I was pretty surprised because it was the Buzzard Coulees meteorite.
Nice. That has really, really super crust for a Buzzard Coulees.
Yeah, I was pretty happy to finally get this little one. He's 2.9 grams.
Mm-hmm.
And let me flip him over really quick.
What is that noise?
Buzzard Coulees is a witnessed Canadian fall. It's an H6, so it has high metal, and it's gorgeous on the interior. Or maybe it's an H4. It's an H4.
Yes, you're right. It's an H4. Just gonna catch the light.
That's some super fresh crust there, Marissa.
This is the other side.
Look at that. Is that not stunning?
Yeah, I'm pretty excited.
Congrats.
I mean, it's even a little iridescent.
Yeah, look at that.
That's amazing.
Full thick roll of the lip.
Yeah.
And Buzzard Coulees is not an inexpensive meteorite either for a chondrite.
No, it's not.
It's really held its value well. You're lucky if you can get it for like 20. If you're lucky if you can get it, and then you're extra lucky if you can get it for like $20 a gram or plus.
Yeah, I mean, I was I actually got a slice of it from somebody, ironically, not in Canada, and they have an export permit for it. I wanted an individual, but all the Canadians that I reached out to, they either wouldn't respond or, you know, they said they would look, but they never got back to me. And I know that it's probably tricky because of the export permits. But I thought, okay, well, if people said they had some, that they went and found them, you know, maybe I can get in on that and I can buy one. But I was a little disappointed that nobody would sell.
Yeah.
But then on that very same day I got that one, I got this guy.
Dang.
He's another Buzzard Coulee, and he's 25 grams.
Damn.
Nice. Pretty nice.
Go big or go home, Marissa.
Yeah, I that was a surprise.
Look
I
at
did
the
not know
metal.
this was- I had no idea that this was coming.
That's gorgeous. You can see the metal sticking out prominently. Do you want to give a plug on the supplier of that? You don't have to. You know, if you just want to give them a shout out, you can. If you want to keep that private, that's absolutely personal information as well.
They never said that they wanted to remain private. So my friend and hunting partner that went on my trip with me, that helped raise, he did the fundraiser to get me out hunting. He Rogan Henny up in Canada. He got to talking with a friend of his named Doug, and Doug is the one that was very generous and sent this to me.
Wow, that's fantastic.
Wonderful.
Yeah, I was floored. I couldn't believe it. All the time I was trying to get Buzzard Coulees so bad, and no one could give. And then ironically on the same day,
one day it rained Buzzard Coulee in your house.
Exactly.
That's a beautiful one. There's a nice crust line on it. You see prominent metal sticking out. Yeah, I have
pretty wonderful piece.
Yeah. Congratulations. That's beautiful. Yeah. That is fantastic. Oh, I'm so happy that you finally got your Buzzard Coulee. That rocks. Yeah, because we go after, if you have something else you want to show off, or was there something else you want to show off, Marissa, as well?
No, that's all.
Okay, I didn't want to cut you off. I'm so happy that you got your Buzzard Coulee, because I know when you go after a stone or a fall, or for some reason it's special to you and you want to hunt it down and you can't find it. Maybe it's from your hometown, your home state or something, or a country of your relatives, and you just go in circles trying to find it. And maybe when you find some people, they don't want to get rid of it. It's a problem. Jesse Allen in Australia. How you doing, buddy?
Howdy. Yeah, so my most recently acquired piece is this slice of 2 out 5 from Craig. And yeah, I love the translucency. My room's pretty light, so it's a bit hard. Yeah, you can see it.
Beautiful.
Yeah.
Yeah. Jeez.
I call it a meteorite slice. Anything that's sliced by his lineman, a meteorite slice.
Slice.
He doesn't like no one else. Like, yeah.
That is awesome.
And on the theme of translucency, I also got this order from. Let me see. That's it. There we go. That's a moldavite. The color's not showing up so nice, but I got this from Sean Mahoney, and the Libyan desert glass. So I didn't really have any any tektites in my collection, so yeah, figured to bite the bullet and get some of those. So yeah,
I've heard rumor that Libyan desert glass is about to go up in price a whole lot. Have you heard that?
No, maybe that's a rumor I'm starting because I was having buyer's remorse. No.
No, I heard, well, because I wasn't in the game this long ago, but I'm told you could buy dump trucks of NWA, really, 869, super cheap in the day. You can buy them by the 55-gallon drum. Then you could buy Moldavite, and it was super inexpensive. Now it's like thousands of dollars per, ridiculous, $25 a gram on some pieces. I was told that there is a new run on Libyan desert glass, and the reason for its popularity is not scientific and super cool awesomeness. It's a new TikTok trend. There's some, I don't even know. I'm 49 years old. I'm 49 years old. I ain't got time for TikTok. So I don't know what it is, but I've been told that if you have some Libyan desert glass, you may want to hold on to it. Wait for the price to go up.
As the ambassador of the younger generation, I failed to stay informed of the TikTok trends.
Well, congratulations. We thank you. Hey, Alex, what you got for us, man?
Hey guys, Marissa just made me think of something, talking about how difficult it was to get Buzzard for her. I wanted to put a quick PSA out there. If anybody knows how I can get my hands on a piece of Willamette, I'd love to. I live 20 minutes away from where it was found and often go over to the park there and really enjoy the spot. So I'd love to get my hands on that.
There's a Willamette on eBay right now.
Is there?
It recently was put up there. I got a bunch of automated trackers on eBay. And so pop up that match, and I see them right away.
Cool, thanks, Raymond. But yeah, if anyone else has a piece they're looking to sell or knows of one, let me know. I'd love to. That's kind of the dream piece that hoping to get sometime this year.
Okay, awesome. Well, hopefully the dozens of people. Now there's thousands of people that will watch this, hopefully, and we'll get the word out there for sure. I'm gonna hit pause for 1 second. All right. I figured I'd show off something that I was super proud of and super nerdy, but super cool. This right here is my custom made Apollo 12 auxiliary switch panel, made to the highest specifications. And these are metal, the switches, these are glove guards. I'm hiding the front because I don't want you to see what it is just yet. But no, it is made to the highest caliber of manufacturing. This is Topher's status. Do the scammers have me heated, or am I kind of in a nominal or chilled mood? Am I at max G, or am I feeling nominal? Dude, you better not deal with me if I'm volatile. But when I'm in social mood, so right now I say I'm chilled, I'm neutral, but I'm very social. So that's Topher's status in my Apollo 12 auxiliary switch. These are all made for their oversized gloves, so they couldn't hit two buttons at once. And the buttons actually rotate with the gloves so they can get full contact on there. If anyone is interested in, they have all kinds of different ones you can buy that are custom made or ones that were actually, NASA, lettering, all NASA on it. So if anyone is interested in picking one of these up for themselves, I have a code to show that I have to pause for. Yeah, so that's one cool item that I have that I wanted to show off. That's non-meteorites. This is another one, a little gift from Juan. I said he couldn't show up today for the because he's in Niger hunting dino teeth. He sent a little dino necklace. I don't know what this is from, to be honest with you, but it's old. He knows I'm also a sand collector, so check this out. This is sand from Mauritania, and he has this it on there where it's from, and I looked that up on the map.
Chinguetti?
Yeah.
Chinguetti.
Isn't there a meteorite Chinguetti?
I'll have to look. I'll have to relabel it. But I thought this was really cool because if you look at the display and this just the the container it's in, it looks really awesome. This is like a tiny little ashtray or something. This just screws off. I don't want to take it off right now, but it's literally just a tiny little mini Coke bottle. But I thought that was really cool because I do collect sand from different strewn fields and African deserts.
So
and I got
there's
this.
a
Go ahead.
I was gonna say the Chinguetti. I remembered there's a big mystery about Chinguetti because back in 1916, someone reported a humongous iron, stony iron there, and I think this. I'll have to reread the story, but it's on Wikipedia. They never brought it back, and then nobody was ever able to find it again.
Wow, something to research. Yep. This is something I wanted to show off for quite some time because I got it a while ago. This is a very generous gift from Gavin Wright. He was actually at the Wabar crater in Saudi Arabia and picked me up sand that also contains Wabar glass.
Cool.
And there's also white silicate chunks in here. I don't know if I'll be able to see them. Yeah, there's one right there. See it? That has something to do with the crater and what went on, the impact of the event. But yeah, this is really cool to not only have Wabar sand, but glass as well. You can see in there. That's really cool. So Gavin, I know it took me a month to finally thank you, but thank you. That's really cool. I'm really happy with it.
I've got one more toper, real quick one, if you want to shoot over to me.
Go right ahead.
So I've kind of been going nuts on buying meteorites here lately.
I love it.
So I went out to the mailbox and there was a strewn field in my mailbox. These are Chelyabinsk from Galina, who is a local there, and there's a scale cube for scale. But these are all amazing little beautiful, completely oriented, fully crusted Chelys, some with like riders on the back and big old drip points, and couple of them even have iridescent crust on them.
Wow. That I love Chelys. I love Chelys, man. They're the big ones, the small ones. The only thing I really don't like, to be honest with you, are the impact melts. It looks like the one at 1 o'clock appears to be an impact melt. Is that true?
I have not looked at them. They've not spent much time in the lab here, so not under the microscope yet.
It may be either super fresh on that one right there that you're pointing at, yeah, with the light. It's the one at 1 o'clock for us. It's either super fresh crust or it looks like an impact melt. Which impact melts, I really don't think. I mean, they're not as beautiful as Chelys, as you know, as a regular stone.
Yeah, they definitely have a very different appearance, of kind of an unmeteorite-like appearance.
Yeah.
Yeah, I think that one is just super fresh crust.
Well,
and
good for you.
I'm working on trying to up my camera game. This little webcam is, well, it's not a webcam, it's a document cam, but it's pretty disappointing. Anyhow, back to you, Topper.
No problem. Let me hit pause real quick, and then we're going to go into Meteorite 101. All right, guys, it is now time for our next installment of Meteorite 101. And this time we are going to be starting with, well, last week we started with, let me get my laser pointer. There we go. Last week we started over here with the beginning of a meteorite / asteroid and how it made a stony meteorite. Now, the next step in today, we're going to be talking about iron meteorites. So if you remember, just a 30-second review, as the material statically charges and collects and combines and builds and grows its own body into such a big piece where now it has a little bit of a gravity pull, it's pulling more and attracting more material to it. And there we go. So we're at that point now where there's actually radioactive decay going on that's building up heat inside this planetesimal. We have to go all the way through the differentiation, which is what this is happening, to where the core has so much heat and so much gravity that the heavier metals are pulled towards the center and the lighter rock material floats to the outside. Last week, we discussed the stonies. Now we're discussing the iron core. So imagine this big planetoid or planetesimals out there in space, and something comes along and doesn't just nick it or roll past it. It actually smashes and obliterates it, rips it to its core, literally spilling liquid metal out in space. That's what we're talking about today, folks. So here is the eye chart that is really truly an eye chart. Last week, we focused on this part right here. Just the L, 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 and H's. Now, of all meteorite falls, 94% of them are stonies, and 86% of them fall into this range, and you can see high numbers here. Well, today we're going to be dealing with this 5%, the irons. Now, the irons aren't broken down nearly as detailed as other things. You can see the chondrites that just go on and on and on and on and on. The chondrites go pretty deep, and then these are all carbonaceous chondrites. We're not worried about anything. We're going to revisit this slide weekly. We're only dealing with this 5% right here. So 5% of all meteorites, is that really a true number? Well, we don't know. The Met Bull, when you look at the concentration of iron meteorites or percentage of iron meteorites that are recorded, it stands at 5%. When you contrast that to the numbers of actual meteorites, as we discussed last week and several weeks, EMSMET in Australia, Antarctica, collects meteorites, and they collect every single one and they classify every single one. Their meteorites are more in the 0.4 range for irons. Why the big delta? Why outside of Australia is it 5%, but it's 1/10 of that in Australia? One major reason, as was brought up earlier by Jans in Germany, when he went to Australia hunting Mundrabilla, he's using a metal detector. And when you get a zit, 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 a really strong signal, and you dig down and you recognize this hunk, there's no doubt it's an iron meteorite. Sitting on the surface, they're easy to identify. They're just a lot more obvious to people. So they're probably more commonly brought in for classification or more recognized as a meteorite rather than stonies.
Yeah, absolutely. The nickel iron meteorites are totally, completely unlike the rocks around them. We call it being out of context. And so they do get recognized much easier. And amongst the Antarctic finds, there's also another extremely interesting idea that, in Antarctica, it very, very, very rarely gets above freezing. But there are periods of time when the sun shines, and the sun shining on a piece of metal for some period of time will warm it up enough that we think that part of that collection of iron meteorites actually disappear below the surface because they melt into the surface.
That's a really cool hypothesis.
Yeah.
Well,
and
what about the York meteorites, which were the northern hemisphere? That was all sub-zero weather, But weren't they large enough to be above the surface?
Yes, absolutely. They were found on a rocky shoreline as well. So yes, they were sitting on rock, and they didn't have a chance to sink into anything. And it's a good point, Ben, too. Historically, a lot of the meteorites that we identify with that you go to the Smithsonian or to the American Museum of Natural History to go see are the giant nickel iron meteorites. And because they are so strong, they tend to survive passage through our atmosphere better than the stony meteorites. And because they are iron and nickel and cobalt and some other stuff, they're closer to stainless steel than they are to straight up steel, straight up iron. And so they tend to weather reasonably well. So the great
Is that because of carbon abundance or carbon shortage?
It's actually because of a lack of carbon and a greater percentage of nickel and cobalt and some of the other stuff.
Thanks.
So when we talk about meteorites and classifying them, what we're trying to do is find a bunch of meteorites that have extremely similar makeup, chemical makeup, and chemical properties. When you have enough that are similar, in this case 6 is the rule of thumb, once you have about 6, you can create what's called a group. Well, iron meteorites fall into one of 12 groups, and those are based on their structure. We're going to show you their, you saw the Mundrabilla earlier, the structure inside. And they're also, so you can look at a meteorite and kind of know roughly what class it is, but that's not 100% science. The way to really find out what it is you resolve that by looking at the gallium to nickel and the germanium to nickel ratios. Once you have those plotted out, and that's what we were actually viewing in that last chart. What we're seeing here is
that one's iridium and nickel.
No, yeah, iridium and nickel. I have it later in the slide deck, sorry. But so here are the 12 classes of meteorites, and I know that I'm not going to do this very well, but Mike Kelly could kick my butt at this. But if you look here, you're literally looking at the 12 classifications of meteorites, of iron meteorites. Excuse me one second. Okay. So if we look at these a little closer, you have different patterns inside these different classifications. If you notice, there's different minerals included in these. This one has nothing. And when you look at these, they may look pretty similar, but once you start and really study them and look at them, you start noticing the intricacies and the differences within them. And then of course the chemical analysis, we're talking about like this one right here. Well, this obviously has some mesosiderite material in it. You see the green here represent cohenite. So this is how iron meteorites are classified, by their pattern and by their chemical structure, chemical makeup. So here are 3 meteorites. Can you guess what they are? Can you guess their classification?
Is the middle one Campo?
The middle one is Campo. Correct.
And the right one, I'm guessing, is Gibeon.
It is not.
Oh.
It's often confused for Gibeon.
The left one kind of reminds me of Munianalusta.
Exactly.
Yeah.
This is Munianalusta. This one is Campo di Cielo, and this one is a very rare classification, 1 of 5.
The left one is 1 of 5.
You have Alte, Campo di Cielo, and Munianalusta. So if you look at, this is a 3E anonymous anomalous. So you have a 3E here, but it doesn't quite fit into that family. When they do the chemical analysis and everything, it literally doesn't fit into that family 100%. It has some anomalous features to it, so that's why it has the AN next to it. If you look at the Campodicello, it fits in the IAB main group, which is right here. The Munianalusta IVA, you can see right there, and that's why Pat confused it for Gibeon, because they are the same classification.
Yeah, so let's take one little step back here. One of the things that really identifies a metallic mass as a meteorite are the Widmanstraten pattern, and they should probably also be called the Thompson pattern, because a fellow named Thompson found them before Baron von Widmanstraten did. But what we're seeing there is, because this is mostly iron and some nickel, and then about 0.5% cobalt and 0.5% a whole bunch of exotic stuff, iridium and germanium and a bunch of exotic stuff, but mostly we're looking at iron and nickel. And as the liquid metal cools, the first crystal structure to form is taenite. And that one is easy to remember, that it's the high nickel one because it has an N in it. So taenite is the the thin lines that we're seeing there, which are actually plates, of course, if we looked at them in 3D. And those form first, and then and they are higher nickel. They're a body center cube, which, talking about the crystalline structure, but let's just keep it simple. Those are high nickel. And then as soon as it's depleted enough of the nickel out of the melt so that the ratio is right to make camosite, which is the low nickel body center cube crystalline formation, then the rest of it forms camosite. So that crystalline pattern, and you can see the width, the difference in width of the taenite plates. The Munianalusta.
Two slides from now, we're going to be talking about the bandwidth of them as well.
Okay, good.
I'm really glad you brought us back a level, because we want to be top level. I totally missed the fact that we are talking about Widmanstraten patterns, and we're talking about the cooling and time ratio and cooling of a meteorite that causes this. It cannot be duplicated, and it cannot be faked. We're talking about I've heard numbers as slow as 1 degree per 1,000 years of cooling.
Actually, even longer than that. Somewhere in the millions of years of cooling.
We're talking about a very, very, very long time, a very slow cooling process. And the kind of way I describe it at rock shows, because at rock shows you don't have time to deep dive like this, I basically tell people you have nickel over here and you have iron over here, and they were mixed together, but they really don't like each other. So over time they basically form their own lines and say, look, you stay over there and I'll stay over here. And that's what we're having. We're having the separation of the materials. There is as you can see here, there are preferred or more common irons, like the AAA, triple AB, I'm sorry, that's a predominant one. Also down here, and there's silicate bearing ones and magmatic. Mike Kelly was talking earlier about magmatic and how those come out of volcanic activity and are cooled first.
Sorry to interrupt. But going back to the Widmanstraten patterns, you know, and the rate of cooling. Now, is that cooling, is that brought on by the, I guess, explosion of the planetoid? You know, and how is the cooling able to be so slow if space is so cold?
Great question. So if we very shortly backcast to our big blob of all mixed up stuff before it's differentiated, if it becomes a large enough mass, it will have the short-lived radionuclides. Aluminum-26 is the most common one and one of the more energetic ones. Between that and impact heating, you'll melt the whole body. And as Topher mentioned, when that happens from gravity, the denser stuff, the 7 gram per cubic centimeter metal, will flow to the center, and you'll wind up with a metal core. And the cooling rate is just about the short-lived radionuclides and the impact heating, about that subsiding over time. And because you have the iron core buried in this big body of rock material, the mantle, and then the little light silicate stuff floating up on the crust, but because it's buried in that big body, and because that forms essentially insulation and thermal mass, that's how you can get that very, very slow cooling rate. And that gives the metal in the core a chance to first form the taenite plates, the higher nickel crystalline structure between iron and nickel. And then when you've depleted enough of the nickel, then you form the camosite in between. Did that answer your question, Luke?
Yeah, I think it did. That, I guess that explains how they're formed, but then is there any modification to those when, so it sounds to me like those are formed, I guess, while the planetoid is still whole. Is there any modification to those patterns when if and when a planetoid, blows up from an impact, is there enough heat and energy there that it can either change or alter those patterns? Is that something that we know, or?
Yeah. So
hey, this is Mike Kelly. There are some that have re-annealed patterns. So you can see the original crystal structure in there from the camosite taenite, but within each individual grain, then you'll see that they've recrystallized from the material. So yeah, there are secondary processes that cause that, and you'll often hear those called annealed irons.
Right.
If you wait 1 second, here is a piece of Rioborn, which is, I believe, Australian. Let me see here. Do I got a video? Anybody see this?
Yeah, we can see you. Looks like
okay. Let me turn it around.
Yeah.
I still see the shared screen. So if you look at the pattern there, if I can get on it.
Oh, now I see it.
You can still see the original crystal structure in there, but then each individual grain has recrystallized and has grains within it.
For people watching, if you double click on Mike Kelly's screen, it'll blow up.
And so yes, Mike is exactly correct. There are some processes that can cause the nickel and iron to recrystallize. There's also some mechanical processes that can bend and distort the taenite and camosite plates. But in general, those are very much the exception rather than the rule. And so when a planetesimal is disrupted, the nickel iron material has a high enough tensile and compressive strength that it generally doesn't change very much. And so what we're seeing there are pretty much, with a few notable exceptions, are pretty much the unaltered core of a failed planetesimal.
That is really, really interesting. And do we know, is there, so we say iron meteorites are 5% of meteorites. Do we know what percentage of that 5% is recrystallized? Is it 1% of that 5%, or is it that rare? Is it
I think it's
30%?
probably in the tenths of percent. Mike?
Yeah, I don't know the number off the top of my head. That would be a great search just through to see if it's listed in the Met Bowl and see how many times it pops up. But Pat, I'm with you. I'm guessing just based on how many times I've seen various ones that mention it. Personally, I would go with like 0.1% as a ballpark.
That's very, very minimal.
Yes. And so, you know, the nickel iron material is really amazingly strong. And these Widmerstatten or Thompson patterns that we see in them are amazingly durable through all of the astrophysical processes.
That's great. Thank you guys for explaining that.
No problem.
Before we get too far away from the whole metal core thing, could an explanation or a clue to the ratio of metal to stony meteorites be seen in the composition of our own planet? Because
yes,
our metal core is only what, like 30% of the planet itself.
It's even less than that, actually. Yeah. When we look at undifferentiated meteorites, you know, when we look at ordinary chondrites and such, and look at the bulk amount of metal that's there, that's typically in the 15-ish%. Now that's grabbing from memory, but 15-ish% is pretty common. It ranges from, you know, 1 or 2% up to 40%, but I think kind of the fat part of the curve is around 15%. And so, yes, we definitely can look at undifferentiated stony meteorite material and get an overall bulk percentage metal.
So I have these on the screen right now. These are 4 different examples of iron meteorites. The reason I have the 2 on the top is those are complex and silicated. And I'm not just saying that because they're busy, but they are silicate bearing and complex. Down here, we have normal, pretty much thick Widmerstatten patterns. On this one, we have a really nice, probably a graphite inclusion. Does anyone want to take a guess at naming any of these meteorites?
Upper left, maybe U80 station?
You are correct, sir.
Okay.
Upper right looks like it could almost be Vaca Muerta.
It is not.
I'm going to guess silicated Campo, but that's a wild ass guess.
It is not. But the one on the bottom here with this inclusion is my only slice of this. And I thought it was really cool. It's not a meteorite that most people want in their collection because it falls apart. Nantan.
Mm-hmm.
Yep. So we have Maslilanino up here for the IAB complex, which represents the highest percentage of silicate-bearing iron meteorites. The Nantan being IAB is also a very common one, where it's not even on the list. It's not even on the list. Wow.
Yeah, well, 1AB, sorry, irons are not my specialty, but the 1ABs I don't think are ultra common.
Yeah.
You got IABs down with the silicates. It's a complex. So like Toluca is also 1AB, but they have a subgroups. There's like 5 subgroups and a bunch of duos and triplets that fall under the 1ABs.
Thank you, because that's right. These are both AIB complex, and this one is an ungrouped one. So it's half as rare as this of the Maslilanino. This Toluca is a really rare one as well. I think there's not that many of those classifications out there. But I was talking earlier about how it's scientifically, they're classified into these groups. And you can see here it's plotted. This is what I was talking to earlier. Nickel versus gallium gives you a plot, and nickel versus germanium gives you a plot. And if you have an item that plots right about here on both of these, you can pretty much assume it's a 3 CD. Again, if you're doing some tests and you have a result that ends up right here and also right here, you can pretty much assume you don't have a meteorite or you have a super special meteorite. you have something that you should throw away or something you should rush to your lab.
So one of the really cool things that's happened within the last 10 to 15 years is that XRF machines, X-ray fluorescence machines, have become much more common. And even though they're still, you know, tens of thousands of dollars, they're way less expensive than they used to be. And so for people who collect metallic nickel iron meteorites, being able to measure germanium, gallium, and a few of the other important trace metals in nickel iron meteorites reveals a lot of information.
Yeah, exactly. We're talking about parts per million here. So we're looking at a higher ratio. This is of nickel, 25%. This is percentages, not parts per million. So don't let that confuse you. It's a wide difference. There is so much more nickel than there is germanium. We're talking about percentage of overall content versus parts per million, and that's the same for nickel. So I wanted to highlight that and make sure everyone out there realizes these are percentages of total content. This is parts per million. We're talking about this one, the IVB is like less than 1 part per million of gallium and less than 1 part per million of germanium, but up to about 18% of all nickel and in the item. So if you get a result like that, you know exactly what meteorite you're looking at. So that's why the 12 classes or groups, I'm sorry, the 12 groups of meteorite, iron meteorites exist, and here they are. This information is not up to date. So the number of falls and frequency, it's a time capsule of information. It's not current. But
Topher, could we back up 2 slides for one quick point? So it's quite interesting that there are other materials in with the metal here, and that may be just a bit confusing. The super simplified version of a planet is that you have the metal core that's just metal, none of the silicates, no olivine, just metal. And then at the edge of that, you kind of have the interface between metal and some of the stony parts in the mantle of the planet. And so that's the difference between the ones that are straight up metal and the silicate bearing and olivine bearing transitional ones. Okay. Oops, you're muted there, Topher.
Thank you very much. I appreciate that. If you look down here, they have the abbreviation. You can do a screen grab of this or a pause if you're watching on YouTube, but because I'm not going to go into it all. But it shows you the abbreviation for the class, and that translates here into the structure. Then the nickel percentage, gallium parts per million, germanium parts per million. So this is a rough guide to figuring out what iron meteorite, how the labs figure out what iron meteorites you're dealing with. So that was all I had on the agenda for the class today. Does anyone have any questions? And again, I don't mind digging in, but I don't want to go too deep for other days.
Not to go too deep, but I just have a question about attack sites, being that here in Arizona, a good sized one was found in Yavapai County. Is since it doesn't have a Widmanstätten pattern, is there some other way of identifying it other than with an XRF gun?
Good question, Ben. So there's a couple of things that make the ataxites stick out compared to normal terrestrial rocks. So we don't see the Widmanstätten or Thompson pattern, but if you're really good at polishing and really careful at etching, you can bring out Van Neumann lines, which are just kind of streaky lines that are all parallel. But when we look at the metallurgy of these things, it's not unheard of, but it's completely exceptionally rare to see metallic iron and metallic nickel from any sort of a natural terrestrial source. And because the ataxites are very high in nickel, in the 20-ish% sort of range, off the top of my head, those meteorites really stand out from terrestrial rocks. And also because they are getting closer to a stainless steel and that they have much higher nickel content, they tend to weather very well too. They last a long time in a terrestrial environment.
Well, thank you everyone for joining us for Meteorites 101 Class 2 Intro to Irons.
I've got a quick question about the appearance and the cooling rates. What by the thickness of the lines, the Widmanstätten pattern, can you tell how large the parent body was and how slow it cooled, or is there anything to say if it's got a really fine Widmanstätten pattern, then that means that it cooled at this rate, and if it's got a coarser pattern, then it means that it cooled at this rate and came from a body that was this size? Or is there anything like that we can tell about size?
I think there is a correlation, but we're at the edge of my understanding off the top of my head.
Why are you still alive?
I think there's I think there is correlation there, but I don't know what it is right off the top of my head.
We'll have to return to that in class 2.0.
Hey guys, can I show something off real quick?
Hold on one second. Let me pause. All right, we're checking with Mike Kelly now.
So cruising on down.
Is this the attack sites?
So this is the whole shebang that I've got so far.
Good.
So you'd mentioned, if things plot outside of the range, there are a bunch of iron groups out there. I think there's dozens to, I think, low 100 of those. So eventually those could pop into their own groups and plot in those areas where you didn't see anything. But there's Chinga, which is a iron ungrouped. Moving on down, you got the IABs. And on your chart, you had the CDs in there. The three CDs and the IABs have kind of been grouped together. And those three CDs have become subgroups of the 1ABs now on a lot of the classifications. And you had mentioned that those are some of the ones that silicate. So there's a silicated Campo.
That's beautiful.
And on your chart, you had down that they do blend all the way into the Winonites.
Mm-hmm.
So the silicates in the Winonites are related to the silicates in the IABs. Then you got the 1Cs, which was a rare group. That's Mount Dueling from Australia. Mm-hmm. Pat had mentioned the Newman lines. So this is a 2AB moving on down, and that's Richland. And that has Newman lines in two directions on it.
That's a beautiful example of Newman lines, man.
Yeah.
2C, don't have one of those. 2D, nothing.
Nothing Arizona.
Yep. 2E, iron. This is
Toluca?
Same Chen.
Oh,
so that's the metallic part of it, and that does blend into pallasites. And the 2Es was that other group that you had silicates into. So there's a Miles, which is a silicated 2E.
Mm.
Moving on down, Balambala.
Oh, that's UL bid me on that one.
That was from a cutting session.
Oh, okay.
This one is Twansburg 2G.
That's from Switzerland?
Yeah, I do believe so, yes. Mm-hmm. Yeah. Hembury, which we talked about, Australia.
We lost your camera. There you go.
Oh, there it goes. Yeah, I got a little power warning on there. And Barry, we're talking about the irons. Moving down to the 3Es. We have one of the NWAs for 3Es. And again, these were on the chart as, not very many of them at all. Moving on into the 3Fs. Again, I think there's like a 5 total of those. 1 ABs. We had mentioned Muniana Lucia. And then no IVB. But that's the way I'm trying to structure the iron collection. Because like you mentioned, I'm trying to go for one of each type.
That's the chart I just showed you guys in real form. I love when that happens. Awesome. Thank you very much, man.
Yeah.
Okay, let me pause. All right. It is that time of week where we take a look at Mars and see what's going on there. I changed these pictures up a little bit. I thought this was a really cool one here, how the rover was stowed for transit to Mars. Thought that was pretty cool. Did you guys hear though that unfortunately the Mars Perseverance rover is falling apart? I'm dead serious. Yeah.
Oh, was it built by Tesla?
It's only been up there a month and parts are falling off of it already. I mean, it's how many billions of dollars was it? Well,
so was that actually a structural part that fell off, or was that an access, get access underneath that panel thing?
So let me turn the volume down on that because that was probably loud. What we're looking at here is the underside of the rover. They kept that as 100% pristine as possible. Now it's exposed to Mars. And if you look right, let me get my laser pointer. If you look right here, this is the robotic armature that will swing over here and get the samples, rotate back and put the sample tubes in the tube holders. So these are the tube holders that we talked about several weeks ago. The tubes, the collection tubes being the cleanest thing on Earth. Well, these are where the tubes are going to be in the rover. And that is why they left that panel behind, because now they're on Mars and they want to be able to stow the samples. So let's just watch this one more cool time.
And Topher, we're not hearing any audio off of the video.
Yeah, I turned it down. Copyright rules.
Okay, I understand.
Yep.
Now, will they be picking that panel back up to close the rover in order to bring it back, or?
Nope. Last week we talked about the Sherlock geocaching marker. The geocaching is exactly what it sounds. They're getting a place, and caching stuff there. So literally they're putting the geocaching marks where the sample tubes are pooped out of the rover, and they'll be able to come and collect them on a next mission. So that's and there's going to be, to steal a term from meteoritics, there's going to be dense collection areas. They're not going to drop them randomly. They're going to drop 5 or 6 at a time and then go pick up 5 or 6 at a time. So that's the plan as far as I know. What we're looking at now is, this is actually not from Perseverance. This is from Curiosity that's been on Mars for years. I thought this was really cool because everyone knows that Mars is the red planet, but the reason it's red, we talked about over the last few weeks, is the outside. There's not that much atmosphere, but there is atmosphere, as the next slides will show. And that atmosphere, even though it has a fractional percentage of oxygen, it still results in rusting and oxidation to the surface. So this is Murray formation, and what they did is they came over and swept it off, and literally underneath the oxidized layer of dust and everything is the actual color of Mars, gray green. And I have Mars in my possession, and it is unique to look at. It is not red. So I thought this was a cool image to share, even though it's from Curiosity, as it says up here.
One caveat there: you see those white veins?
Yep.
Those are not hydrothermal veins.
It says they're sulfate minerals.
Yeah, sulfate minerals in little cracks, but they're not hydrothermal quartz.
Gotcha.
That's one of the common. It's not a meteorite indicators.
One thing that I thought was really interesting is this again is off of curiosity, but watch the sky. Have you ever seen Martian clouds before?
No.
That's cool.
Oh, wow.
That's wild. Mars has an atmosphere. It's not much. And shout out to iGadget Pro. I commandeered that little clip from a much larger segment, and I'm adding my narration on top of it to add value to it. This is a cool little thing that I'm going to let it run. Now, this is a combination of two things. This is Curiosity, the rover that's been on Mars for a while, showing us this cliff. And I'm going to have Pat talk about the formation a tiny bit and how it relates to meteorites and what not to look for in meteorites. But while we watch this, we're going to listen to audio captured from Perseverance within the last 48 hours. This is what Perseverance sounds like as it physically, electronically moves and actuates itself over the Martian soil. So hopefully this will blow your mind like it did mine earlier. So here's the video. And here's the audio. Come on. Geez, let's try this one more time, folks. Are you guys hearing audio from it or not?
No.
We can't hear the audio.
Okay, let me pause for 1 second. All right, technical issues are resolved. So now we're just looking at a nice panoramic. I'll let you pronounce that.
Montmacu. I don't know. My French is horrible. But you'll notice that there's cracks going down through the layers of this obviously sedimentary body here. And if you look in the cracks, there's sand. And so the blowing wind in the Martian atmosphere blows that sand around, and you get erosion from that sand, just like you do in many places on Earth. And this obviously is sedimentary, but generally, and we don't have any sedimentary meteorites. Yeah, there's your sand, and to the upper left a little bit there too, wearing through the cracks. We don't have sedimentary meteorites because with a planetary meteorite, to be able to eject material, it has to be hit really, really hard. And so the igneous materials that we have in our shergottites, nocolites, etc., are quite tough and don't really alter a huge amount, although every planetary has a significant shock value. The lunar regoliths that we have were soil on the moon, and they got whacked hard enough to turn it into a solid rock. So if sedimentary rock gets whacked like that, it is altered enough that it's no longer sedimentary. It's metamorphosed, not different than the ordinary chondrite metamorphosing, but it's changed from the impact. And the new landing site that we've chosen for the newest rover is a really cool one, and will give us some more views down through the sedimentary layers, because it's the edge of a crater and those layers have been excavated and up tilted by the impact that formed that crater. Is that what you were looking for, Topper?
Yep, absolutely. I appreciate that. And it's not so cool because we have to stare at a white screen, but this is the sounds of perseverance on Mars. You can literally hear it getting itself in the right angle, and then you know, driving forward. So really super cool. And we're gonna be checking back. There's still a lot more updates to come on Mars. Right now is it's part of the show where finally I get to shut up. And I know you guys are really happy about that part, most of all. We're stopping off on our tour of the universe, and we had a special guest star come in from Australia. He's joining us. We have Jesse Allen joining us to do our tour of Titan. So Jesse, let me find where you are. There you are.
Howdy.
And I hope you're ready because I'm going to you.
Yeah, I'm ready. All right, so can everyone see my screen?
Yes.
Yes.
Okay, so Titan is where we're going this week, which is one of the coolest places in the solar system as far as moons go. Just to start with some quick background material on Titan. The environment, it's pretty much very close to a 50-50 ratio of ice and rock. So with moons out there in the solar system, you've either got rocky moons, you've got icy moons, or you've got ones that are in between. And it's one of the in-between places, which are, they're the most interesting ones really, because they're the ones that we least understand so far. So those ones that are half rock, half ice, we don't quite fully understand how they're going to behave. The gravity on it, about 14% of Earth's gravity. Its day lasts for about 16 days. So you'd have 8 days of darkness, 8 days of light, depending on wherever you are. And it's tidally locked, so it does one full revolution. The day is the same time as its orbit, basically. Same side's always facing Saturn. Cool. Its orbital eccentricity, about 2 to 3%. What that means is that it's 2 to 3% off a perfect circle. So it's stretched out a little bit like a football sort of shape, but not that much, but it is enough to cause tidal deformation. So what that means is when Titan is slightly closer to Saturn, it sort of gets squeezed up by the gravity. And when it's slightly further away on the outer side of that football shaped orbit, it actually expands and gets a little bit bigger. And that happens up to 10 meters in size. And that's important. That comes into play with the internals a lot. So yeah, 10 meters doesn't sound like a lot, but for a smallish sort of object like Titan, changing that amount, yeah, causes a reasonable amount of internal heating. The surface temperature is very, very low. So a lot of the heat's on the inside. Well, the heat's on the inside on Titan. It's not on the surface, basically. So you're getting close towards liquid nitrogen temperatures here. We're at negative 180, and liquid nitrogen is around negative 196. So yeah, very, very cold. This is the super interesting part. It has an atmosphere. It's the only moon with a dense atmosphere.
Wow.
And so it's about 1.5 the density of Earth's atmosphere. So this is the place in the solar system that the atmosphere is closest to that of Earth. There's nowhere else that has an atmosphere that's this similar in pressure to Earth's atmosphere. And what that means is if you're using a spacesuit on the surface of Titan, the pressure is actually not something that you have to worry about. It's the temperature, right? So the temperature is the hazard on Titan, but it's not pressure. You actually don't even need a pressurized spacesuit. You just need something that heats you up, which is pretty cool. So they say that Titan is the place in the solar system where you would where you could have the most minimalist spacesuit. You could just have something with a really warm fluid pumping through it to keep you warm. That's not pressurized. And obviously you need a respirator too, because the atmosphere, as we got here, there's no oxygen in it. We just got 95% nitrogen and 5% methane. It was the second discovery of a moon after the discovery of the 4 Galilean moons. So they thought it was the largest one at the time. Turns out it isn't. It's second after Ganymede, as we can see over here. And just a little bit on the orbital resonance. A lot of these moons are in these complex systems where they line up, just like it did then. They line up every now and then with other moons, and yeah, it forms a stable sort of resonance. And yeah, it's in a stable resonance with Hyperion, and you can see just then they line up every now and then, and they're extremely close. They're sort of tugging on each other, which is just an interesting part of its orbital mechanics. To give you an idea on its size, we're just talking about Mars. When you look at the size of Titan compared to Mars, it's not that much smaller. We're talking 5,000 kilometer. I'm not sure whether that's radius or diameter there. That'd be diameter, I think. To 6,700. But the mass is significantly different. And this tells us that it is not rocky, that it's got a lot of ice. Yeah. Ice is what causes these low density worlds. But amazingly, it's more massive than Mercury. So that's why Titan and Ganymede are really referred to as like planet-like moons, because the size of them, if they were orbiting around the sun instead of their respective planets, they'd be classified as planets themselves. So Titan is big enough to be a planet. It's orbiting Saturn, so it isn't a planet, it's a moon. Now I thought for this week, I just wanted to go through and show you guys some cool pictures basically that have been taken, because this is a place that we have explored really, really well. And so this is a history of the exploration of Titan, starting with Pioneer and then the Voyager probes to Cassini and Huygens, and a little bit about the future Dragonfly mission. So let's start with Pioneer, which was just before Voyager. The photos that Pioneer took were quickly superseded by Voyager. But I really like seeing that just in a single lifetime, how the knowledge of these worlds has evolved. So, you know, if you were alive in the 70s, this is the best view of Titan that we had in the first pictures. This is Titan right here from the Pioneer probe as this cold, hazy, hostile ball. They thought there's not really any chance that life as we know it could be on this ball. But what about life as we don't know it? We'll get to that. So these are some of the first few pictures. You see Titan is just a little tiny hazy ball here. When we check out the Voyager mission, which was the twin probes, the two launched simultaneously, just to mention, Titan was deemed so important that the entire latter half of the trajectory of the Voyager missions was decided to do a flyby of Titan. If they weren't doing a flyby of Titan, they would have gone on to Pluto, but they basically had to pick what's more important. Do we want to do a flyby of Titan, which will cause our spacecraft to be on a trajectory that forbids going to Pluto, or do we want to go to Pluto? And yeah, they picked to go to Titan. So that's how important it was, that it basically shaped the decisions for where it could go afterwards. These are the pictures, the first pictures from Voyager. And what you should be noticing here is this little tiny extra glow. And that is the atmosphere. This is pretty much the first picture showing the glow of that atmosphere, which is awesome. And we can start to see some banding patterns as well in the atmosphere. It's not just this featureless ball. We can see that there is, almost looks like weather patterns in the atmosphere too. And this is already starting to get more interesting. These are also photos from Voyager that show that glow when it's eclipsed. It's easier to see the glow of the atmosphere, and you can see that there's actually multiple layers or hints of multiple layers in this. So this was really the basis of well, and this next one, which I'm going to show you, which is the most famous image of Titan from the Voyager missions. This really shows that glow up close. And this is a true color image. A lot of stuff you see from space is false color or taken with other types of light. This is true color visible light. So this is what it would actually look like if you were seeing Titan there. Which, yeah, I don't know. I think that's pretty awesome, seeing somewhere that has that sort of blue glow in the same way that Earth's atmosphere has the blue glow from space. From this, they were able to get a fair amount of information about the different layers and, yeah, based on how the radio waves or the radar was penetrating the atmosphere, they got some information about the pressure, yeah, as well. So it's pretty cool. What I find fascinating about this, this was the most advanced information that we had until the Hubble Space Telescope pointed itself. And on these two columns here, you see pictures from the Hubble Space Telescope. And so, yeah, the Voyager missions flew by in early 1980s, or 1980, 1981. It wasn't until 18 years later that we got to see a little bit of a hint of what might be underneath the surface, because it's so hazy you just can't see through there, right? So the Hubble Space Telescope showed us that there were these dark and light patches, and this is using near infrared light, which peers through the atmosphere to reveal light and dark patches on the surface. What's fascinating is that the same data, the same pictures from the original Voyager missions ended up being reanalyzed with modern technology, and they produced better images than these Hubble Space Telescope images. Obviously, they're really close. So this column here is the reanalyzed images from just a single color, because there was 3 colors on the Voyager probe. This is just from the orange filter, and it gives information about different surface topographies, basically hidden in that orange light. And this was only from extremely advanced image analysis that they were able to do this, and it was done 24 years after this information was collected. So it's pretty cool how you can get old data and something that just looks like a featureless ball. You can reanalyze that old data, and this is basically the first peering through to the surface. And that brings us to the next mission, which was Cassini, because Cassini was carrying these near infrared cameras that could peer through the surface. And so things get a lot more interesting with Cassini. So let's take a look at some of the stuff that it got. First off, just starting with some nice overviews. Cassini had amazing cameras that got some great family photos of Titan around its family with Saturn. I love this edge on view. So the reason why it's black here is because the rings are going through here, but the shadow of Saturn is completely blacking out those rings. But you can see a little thin sliver of Titan through the void there. Very cool side on image of Titan.
Yes.
This is a nice little image Cassini took of a ringlet called the Titan ringlet, which is actually stretched by tidal forces. So you can see that there is a big black gap here up the top and then down the bottom, and then it's a little stretched out. This little tiny bit always points towards Titan. So there's a little tiny ringlet that is in a resonance with Titan that's always pointing to it. So that's a pretty cool novel thing about it.
That's very neat.
Yeah, and another, like an image of, we've got 2 moons and Saturn's rings here. This next one I love, 3 moons and Saturn's rings in this image. We've got Tethys, Titan in the background, little tiny small one, which that's not an artifact of the image there. It's not round because it's too small to be rounded, basically. So Pandora is being stretched out from the tidal force. It just formed this weird oblong sort of shape, and then Saturn's ring. So yeah, some really awesome, just amazing family photos of the Saturn system there, a place where you can have 3 moons and some rings in the same view. So pretty incredible. All right, now that was just a little bit of a teaser, but one of Cassini's missions was to do a whole bunch of flybys of Titan, right? So it had 6 close approaches, and in its closest approach, it was going less than 1,000 kilometers from the surface. So that's pretty impressive. So it makes me think of like the Top Gun scene where they buzz past the tower. So this is it approaching with its near infrared camera that's allowing it to peer through the clouds. This is the raw footage of the first flyby. Wow. Now, to give you an idea of why we need to use the near infrared, its atmosphere is all hazy because of this combination of methane and nitrogen, right? We said it was 95% nitrogen, 5% methane. Well, you guys might have heard of the experiment that they do with simulating Earth's early atmosphere and zapping these gases inside a big piece of glassware, and it produces all of these chemicals that are what we refer to often as like the primordial soup, right? They call them tholins when they see them in space, just basically complex organic molecules that have been produced from energy, whether that is lightning strikes, or in the case of Titan, it's just from high energy ultraviolet rays smashing into the upper atmosphere. So we get these quite complex organic particles in the atmosphere, and that's why we have this brown haze. It's not the nitrogen or methane, that would be perfectly clear. It's the reactions of the nitrogen and methane with each other that produces this. And so that's why we need the near infrared. So this was a real game changer. The Cassini was the first one with the near infrared camera that could peer through that haze and show us the surface. And this is an image mosaic from, I think, the first year or so of the mission, with over 9,800 different near infrared images all combined. And it only gets better from this. This is from 2006. And the next one shows how much data we got from Cassini. This was after the first year, and this next one is after the entire, I think, more than 10 years, but in 2018. So after the entire mission was over, this is all of the collated data from the Cassini mission, and just an amazing surface map. So this is the most current as of 2018. Cassini's obviously not there anymore, but they still actually are processing and getting more and more information from that data. So yeah, this is the best map of the surface of Titan. And what I love as fans of meteorites, can anyone spot any craters here? There are a few tiny little craters. If you look real close, you can see one here.
Yeah.
And a crater there, and over here. So there are a few that have been identified. So unfortunately, probably because of the gravity well of Saturn, we don't think that any material from Titan could get shot to us. If there's any collision, the ejected material probably just gets sucked into Saturn because its gravity is that strong. But it's still cool that, yeah, that there are craters identifiable on the surface. And so now I just want to show you guys some of the pictures of those taken during the 6 close approaches. And this stuff blew my mind. I hadn't really looked at these real close-up images before. Oh, sorry, just before that. This is just a black and white image that's taken just from like one band of data, but they actually were taking 3 different bands of near infrared. And so just as we see with 3 different bands of visible light, we see with red, green, and blue. If you get those 3 bands of near infrared data and change them to red, green, and blue, then you can produce a colored image. And that's what they did here. So this is what it would look like basically if you could see, and you know, if you were seeing with 3 different bands of infrared instead of visible light, which is pretty cool.
Very neat.
Yeah. And from that data that we were just talking about, this is the topography map that they've come up with, showing things like craters. We've got hilly terrain, which is shown in the orangey yellow color. We have what's identified as dunes. There's a lot that you can tell about the weather in those dunes when we see with close-ups. Look, the most interesting thing is the lakes, which are mostly up around the North Pole and the South Pole. And so these are huge areas of interest, the Kraken Mare, or however it's pronounced, the massive lake up there. So let's check out some of those close-up zones. This is the Kraken Mare up there. And all of these black spots are basically where the radar is showing a the radar and the infrared. The radar is showing a very smooth surface, and the infrared showing a strong absorbance. So these are lakes, but they're not lakes of water. It's too cold. The water would just freeze to ice. These are lakes of liquid methane and other hydrocarbons. So we've got this massive lake system of liquid hydrocarbons up near the North Pole. And we've got quite complex sort of river systems. You can see here evidence of rivers down here in the bottom and also up in the top left here. And this is a cool infrared image up here of sunlight, actually the sun glinting off a lake. So just a reflection off of a lake captured in near infrared light, which is a pretty cool.
What are the odds to have the probe in the right spot for that?
Yeah, exactly. So yeah, see some of the coolest pictures of surface liquids, which, by the way, Titan is the only place other than Earth to have surface liquids in the solar system. So nowhere else other than Titan and Earth have oceans and lakes on the surface. Even cooler than that, these really, really close-up images. This is of the Kraken Mare up here, which shows in this patch nothing, and then a signal captured in the next one, which they suggest is either waves or floating debris. So yeah, that's pretty awesome that we can actually capture waves or just a bit of debris floating on the surface. And same thing down here, we've got nothing in these photos taken before. Then we've got some sort of wave or debris-like structure in these two here. So yeah, these are in the Kraken and Ligeia, which are here. They've actually spotted some sort of movement basically in the surface of these liquids, which is pretty cool.
That's very nuts.
As for the other terrains, we've got these real linear dunes. They use these to tell about what the wind direction is. Basically, these sorts of linear dunes, they say they form when you've got a consistent sort of wind direction that goes parallel to those dunes, which is pretty cool. And this really weird terrain that's called the labyrinth terrain, which is usually at a higher terrain than the rest of Titan, and it's very sloped, and you see evidence of erosion or fluid flows, basically past fluid flows in these areas. This is a photo showing 3 different ridges.
Oh, wow.
3 different ridges, which are going up to heights of about 2,000 to 3,000 meters. These, so yeah, some pretty massive mountains. Methane clouds. Yeah, so we have a methane cycle basically in the same way that Earth has a water cycle. There is a methane cycle on the surface of Titan, and these are the methane clouds that are captured around these lakes up in the northern part. So the cool thing about the rain, if you want to visualize being in Titan rainfall, it would fall 6 times slower than rain on Earth, and the rain droplets would be 50% larger because of the lower gravity and the difference in surface tension for methane compared to water. So yeah, it would be a pretty interesting rainstorm to be in the middle of. This is a cool compilation of images showing the flow of the South Polar vortex, which they captured. So there's basically a consistent weather system down at the South Pole, kind of like due to the rotation of Titan, we've got that rotation going into the atmosphere causing a storm basically, or a weak storm, yeah. And we've even captured moving clouds. If you look down in this part of the image, you can see the clouds drifting along. Kind of reminds me of the video you were showing of the Martian clouds moving along. And we got some really great, this one, I love this because this is a true color image here. I always love true color images of space. And so this is a true color image showing multiple layers of haze in the atmosphere. So again, we're seeing a lot of near infrared. This is what it would look like. Well, that's what the haze, the clouds look like in color. And other evidence of storms. Here we have 3 different sets. Each column is a set showing the emergence of a different storm. This one here, before the storm, there's nothing there. Then we've got a radar signal that pops up showing that there's a storm there. Or sorry, not radar, infrared detection. And then it disappears. So these middle ones are capturing storms of which there was nothing before or after, but we get this detection on the near infrared in between, and it's just cycling through showing the appearance of the storms here. So we have detected, we've actually detected this, you know, appearance of 3 different storms basically on the surface of Titan, which is pretty cool. So all of these surface images so far were all near infrared or radar, and the only way to get visible pictures of the surface is to physically go through the haze. And so that's what they did, and this was the European Space Agency's role to play with the NASA mission. So just as we're like global, I thought that I was pronouncing it the right way for all these years that I've been calling it Huygens. And some people say Huygens sometimes, and I thought, oh yeah, Huygens is right, but it turns out there's even more correct way to say it, Huygens, but I don't think I can get it. If we've got any Dutch people, then maybe they can show us sometime. But yeah, that was the #1 result when I looked up how to pronounce Huygens. So,
this guy.
So this was the Huygens lander. This is the actual visible true color images taken of it during its landing. Far sped up because the landing took several hours. So this is massively sped up.
Whoa.
And then this is the famous image from the surface. And this image has the distinction of being the image taken from the furthest body beyond Mars, basically. So it's the furthest surface that we've ever landed on, and this is the furthest surface image ever taken. Just to give you some nice snapshots of that landing, this is the visible snapshots at the different altitudes. It had 4 cameras to get a full 360-degree view during the landing. And basically the main takeaway from this was that there were some really dark patches, and they think that's where methane flows have collected tholin runoff. And that tholin is the complex molecules that we were talking about that form in the atmosphere that cause that haze. So basically the haze is constantly settling onto the surface. And so you would get an even distribution of these dirty organic molecules all over the surface if there wasn't any liquid flows. But there are liquid flows. And so what you see is the liquid causes collection of these dirty, hazy molecules in the zones where the liquid seems to be flowing to. And so we can get an idea about where the runoff leads by looking at the darkness of these patches. So that was their main point of interest. Sad thing was that they couldn't see any surface liquids during this descent, which was something they were hoping to see, but they didn't. They actually designed the Huygens probe to be buoyant so that it would float if it landed in a surface liquid. That would have been amazing if it did, because it only had the one camera, and that camera couldn't, well, on the surface, only had the one surface camera, and that camera couldn't move. So if it was floating, we would have been able to get a lot of different photos, but it landed on a solid surface and just took the same photo over and over and over again. And so this is still a quite significant photo, although there's no liquid in sight. In this photo, there's plenty of image of past flows because all of the rocks, I say rocks with inverted commas there because these are ice cubes that look like rocks basically on the surface. They're all rounded just like river rocks on Earth, and that's showing that there must have been some sort of tumbling or erosion that's caused them to look like that. So yeah, that's a pretty exciting image of the surface of Titan there. And just finally, just some data that we've got from these images and the other data from Huygens. We're pretty confident that there is an underground ocean underneath the surface because of that tidal deformation we were talking about. That causes all the content that Titan's made out of to rub up against itself on the inside, basically. And just like rubbing your hands together causes frictional heating, the rock on the inside being compressed and expanded, it heats up and that melts the icy crust to form an ocean. The cool thing about this ocean and the crust is completely decoupled from the rest of Titan. And what that means, being decoupled, it's free to float independently of the inner part of the moon. So it kind of moves around kind of like a gyroscope in a way. What the researchers found is that the outer crust is actually rotating by 0.36 degrees per year, which is equivalent of a shift of 10 to 30 kilometers. So basically the crust is rotating around the core, and the ocean is sort of lubricating that, I guess, in a way.
That's weird.
Yeah, really weird. And so they would take about 1,000 years for the crust to do one full rotation. Yeah, so that's pretty cool. And also from the Huygens mission, they were able to do a lot more complex detection of organic molecules. And this is the most exciting result from that. The results of the recent Huygens probe could indicate the presence of life that is different to life on Earth, because its metabolic products would be acetylene and ethane and hydrogen. So instead of being an organism that you know, uses things like oxygen and carbon dioxide like us, it would have a totally different metabolic cycle where it's actually breathing hydrogen and you know, breathing out acetylene, I think. So yeah, this is what they guess is that in those cold lakes, because anywhere where you have a liquid, that's a good place to have chemical reactions. In those cold lakes, you could have the perfect conditions for this type of weird exotic life forming. I don't have any pictures for this one because it hasn't happened, but we should all be excited about the 2027 launch of the Dragonfly. It's a quadcopter that's going to be flying around on the surface of Titan, it being one of the places with a dense atmosphere, or the only place with a dense atmosphere similar to Earth's. It's the best place for this. And, you know, we're all excited about the Ingenuity helicopter on Mars. And I think one of the reasons that they're doing that is because if they fly a helicopter on Mars, they're more likely to have the politicians and everyone else believing that they can go and do it on Titan too, even though it's a completely different atmosphere and everything like that. Yeah, I think that some part of flying the helicopter on Mars is to prepare in a way for this Dragonfly mission, which is pretty cool.
Very cool.
Yeah, and so as far as the far future goes, I don't know what's coming after Dragonfly, but in 12.5 billion years, when our sun goes red giant, there's very interesting studies that have been done that show that the habitable zone will shift from Earth and Mars to Jupiter and Saturn. And so Titan is predicted to enjoy several hundreds of millions of years in the habitable zone. And where that happens, its icy crust is going to melt, and it's going to be an ocean world, they anticipate, and it will it'll be very favorable for very favorable conditions for life. So yeah, even if it doesn't have life now, who knows what could happen in another 8 billion years or so. And yeah, just to finish it, just some artist impressions of what it could look like in 8 billion years. I think this one on the right is the most correct, because we've got that nice surface ocean. So basically, it could be completely melted and just a really deep water ammonia rich ocean in 8 billion years time. And who knows what sort of crazy things could evolve there. Yeah. Thanks, everybody.
Fantastic. Thank you very much, Jesse. I really appreciate it. Everyone else is on mute, but I'm clapping.
Yeah, awesome, Jesse.
Really,
you may wind up with this job for life, you know, if you do too good a job.
Yeah, no, I'm very appreciative of you jumping in and taking that. We had Juan set to do it, but he was unfortunately called away on business. So yeah, just to clean house for just a little bit. Let me see here. Oops. Let me pause.
By the way, I'll post.
That was a really good presentation, Jesse. Definitely appreciate it. wanted to do a little bit of house cleaning. We're running super long today, but I wanted to ask you a question. When you want to sit outside in beautiful weather, selling bunches of meteorites, but you're not allowed to, you know, the next best thing to do is invite your anti-goatee buddy over. If there's matter and antimatter, our goatees are the matter and antimatter versions of goatees. I'm going for the point, he's going for the wide end. So Chris Monk is going to be here at my house on Saturday the 27th for our live meteorite sale. Not trying to sales pitch you guys, but 10% off. It's going to be about 3 hours, maybe 4 hours. Going to go through a bunch of stuff. I'm going to try to move through it pretty quickly, but give everyone a great deal. Just a quick reminder about my merch shop in case you want to be a member of the Bolide, the Knowledge Bolide team. You can pick up your shirt there. You can do a screen grab. Like I said, I'm going to move quick, so moving on. We have the Faker of the Week on eBay. We're going to only give him as much time as he deserves, which is not much. Super 1 deals. The 1 is a 0. 100%.
Yeah.
Let me do this. He has 100% positive feedback. And now I love the fact when people say things 2 different places, 2 different ways. The meteorite is not tested. I have not had this rock tested. I don't have anything to prove its authenticity or where it came from. Buy your own risk, no returns. It's only $150,000, guys. Sign up now. Hurry. Outbid me because I'm going to be bidding on this piece of crap. Okay. So first off, in his title, he calls it a meteorite. It's not tested, but it's magnetic all over. You know, it has magnetic properties all over. It's not. And then, you know, he says, when I communicate with him, he says, well, the ad says it's a rock. No, the ad clearly says it's a meteorite, but it's not tested. When when uneducated people trying to buy meteorites look at this, they go, oh, it's a meteorite, but it's not tested. So it means it just hasn't gone to the lab. He can't officially call it an L4.
No.
That's not what it means. He's literally just saying, in fact, when I call him out on it and say, he says, you know, just go bother someone else. All right. You know, I think it's weird because my first communication with him is very nice, saying, hey, this is 0 chance it's a meteorite. Please end your listing. Yeah, you're probably right. I'm only selling this because I want to buy a home and for my kids, and the job's not enough. He wants to put a down payment on a house, even though he knows I'm probably right, saying there's 0 chance. So you appeal to their character and say, hey, you know, cheating someone out of money, there's never excuse. If you continue to commit this felony fraud at this amount of money, it's hard to care for your kids from behind bars. This is the kind of crap we see on eBay all the time. So I would warn you and tell you to please go out to Super 1 Deals with a 0 and tell him exactly what you think of his non-meteorite for $150,000 that he admits it's probably not a meteorite, but he'll take your money and for his kids. It's just absolutely pathetic that there's people out there willing to profit off of people who are uneducated. And that's why the Knowledge Bolide crew is here, because we fight for those who can't fight for themselves. So that is all I have for this. Let me stop screen sharing. One of my buddies told me that does it, and it works, Jesse. I'm also going to share this. Everyone should be able to see everyone now, I hope. All right. Oh man, that's kind of clumsy. There, that's better. All right, everyone take yourself off of mute. You too, Jans. Thank you so much, everyone, for joining us today. Super long hangout, but really good information. Again, if you showed something, please send me a message or put it in the chat. Send me a message personally. I'd greatly appreciate it. Thanks, everyone. Have an awesome week.
Great job, Topher. Thank you.
Yeah.
Have a great night, everyone.
My talk.
Cameron, looks like you've got a comfortable cat on you.
Oh, he is.
Yeah. Right on, guys. Thanks a lot, everyone. Enjoy your night, everyone. Bye-bye.
Thank you. Great
Thanks.
presentation.
Yeah. Great job, everyone. See you, Maxime.